All right, well, I finished figuring out how to make these work again. So at least I have a proper looking screen to give you guys this time and not just writing everything down by hand. So let's look at the next thing we want to do, which is we want to talk about solving systems of equations using a concept called elimination. All right, and elimination literally means you're eliminating one of the variables. So instead of substituting and getting everything to one variable, we're going to get it to one variable by getting rid of something instead. This is, I think you'll find that as you get comfortable using this method, that it's much more efficient. And actually, once you get a handle on it, I think it's easier than substitution. To be completely honest with you, there's many ways you can screw up using substitution, and elimination gets rid of some of that for you. So hopefully, this is your introduction to it, and we'll see how this goes. So we're going to start by looking at elimination using addition in this video, and the next video that goes with this will be using subtraction. So pretty much what it says up here is write the system so your like terms with the same or opposite coefficients are aligned. So basically just line everything up, right? Line up your x's and your y's, right? And if you do that, you're in good shape. And then it becomes kind of clear what you can and can't do with that. And then what you're going to do is you'll add or subtract the equations. We're going to focus on adding in this video. Get rid of one variable, eliminate one variable, then solve the equation, and then you'll do the substitution back in to solve for the other variable, which you guys are familiar with from doing the substitution method for the whole thing. So let's take a look at this example right here. So we got 4x plus 6y equals 32. And 3x minus 6y equals 3. So what you're looking for, guys, is you're looking for the variable that has the same, or I guess I shouldn't say same, but it has opposite coefficients as each other. And by opposite, I mean additive inverses of each other. So if you 3 and negative 3, 11 and a negative 11. In this case, we have 6 and negative 6 for your y. And once you locate those, then what you're going to do is you are quite literally going to add these equations to each other, and you're going to see something really cool happen. So I'm going to go 4x plus 3x, right? I'm going to add those two together, and I'm going to get 7x. And then I'm going to add my y's, and when I add positive and negative 6y to each other, I get 0, right? So I get 7x plus 0, and then add 32 and 3, and you get 35. And, that simplifies to 7x equals 35. Next, solve for your x, right? And at this point, it becomes kind of clear what you need to do. And you can see that if I would have had to use substitution on this, like rewrite one of these, like get x by itself on this top equation and then divide everything by 4, and that would be really, really, really messy. All right, and this is super direct and works out really well in this case, right? So I get x equals 5, so I'm going to take this and I'm going to put it back into one of the equations. Let's put it in this bottom one. So let's go 3 times 5 minus 6y equals 3. Okay, so we get 15 minus 6y equals 3. We're going to move our 15. You get negative 12 over here and negative 6y. That cancels out. Divide both sides by negative 6, and you should get y equals 2. So you should get the point 52 for this. So let's put this in this top equation here and make sure we're good. So 4 times 5 plus 6 times 2 equals 32. Well, let's find out. 20 plus 12. Yeah, that works out, right? 20 and 12 make 32 equals 32. You have what you want there. So this indeed is our solution. Looks good. And it was pretty easy. Definitely easier than doing substitution for the entire thing. All right, so let's look at another example here. Okay, so this next one, we got negative 4x plus 3y equals negative 3. All right, so for this one, what we want to do is recognize, okay, which of my variables are going to cancel. So let's rewrite it just so it's a little nicer. I don't like the way this is written. It doesn't, you know, I know it doesn't have to be exactly aligned, but I like it when it is. All right, so if you look at this, you can see that my x's should cancel when I add this together. They have the opposite coefficients as each other. You got negative 4 and a positive 4. So when I do add these together, I will get 0 right here. And then 3 and negative 5 gives me negative 2y equals positive 2. So you get negative 2y equals 2. We divide both sides by negative 2, and you get y is equal to negative 1. Now I'm going to take this, and we're going to substitute into, let's go into this bottom equation. All right, so let's go 4x minus 5 times negative 1 equals 5. Well, these are going to cancel, right? So we're going to get 4x plus 5. I mean, actually, I shouldn't say that. Double negative, it doesn't cancel, it just becomes positive. Use proper terminology, Mr. Simons. All right, so 4x minus 5, so subtract 5 from both sides. You get 4x equals 0. Don't panic when you see that. That's perfectly normal. Divide both sides by 4. You get x is equal to 0. So you should get the point 0, negative 1, where these guys meet. So let's take this. Let's put it in this top equation. So negative 4 times 0. I love multiplying things by 0. It makes things so much easier. So this goes away, and you get negative 3 is equal to negative 3, which is what we want. So this looks dandy. All right, so next video we're going to talk about how to do this when you have the same coefficient on the same variable, but they're not opposites of each other, right? So we'll take a look at that, and you'll see it's pretty easy to deal with. All right, thanks. See you in the next vid.